So we already saw a Ferris wheel question at the getting started. Yes, I have extra sheets. We already saw a Ferris wheel question at the start of the unit. So what I like to do is draw my Ferris wheel, put fancy green chairs on it, and then right beside this is going to sort of help me understand. I guess it needs spokes, otherwise it won't connect to the tower. And then right beside this, I'm going to draw my axes so I get a sense of what's happening with the picture that I've drawn. It just sort of helps me visualize it. So it tells us that our Ferris wheel has a radius of 15 meters. That means from the center to the top will be 15 meters. It rotates once every 20 seconds, so it's not as fast as our 2-second one the other day. We start at the bottom, which is 1 meter above the ground. So this distance here is 1 meter. So the first thing I'm going to do on my graph is I'm going to put 1 meter there. Since the radius is 15, my center is going to be at 16 meters. And the top is going to be at 31 meters. We can label this side as height. Now we know that we start here at the bottom at 1 meter, and it tells us it does one rotation in 20 seconds. So if I mark down 20, I know I'll be back to the bottom 20 seconds later. If we cut this in half at 10 seconds, halfway around, if you start on the bottom, you'd be right at the top. At 5 and 15 seconds, you would be right on your center line. And we can label this down here as time in seconds. You can use this one today while you're waiting for yours to charge. So what I'd like you to do is, okay, right here, it says part B, we're going to estimate the height after 22 seconds. Just looking at the equation, where do you think it's going to be at 22 seconds? 3 meters? Sure. That's just an estimate. Just looking at our graph going up and seeing approximately where it will be, we can guess it to be 3 meters. We're going to find out exactly what it is using an equation in a bit. Okay, so somewhere in here, and depending on our graph, we're estimating that going across. Maybe it looks more like 6 meters. So there's a couple different estimates that we have. You're going to go with 9? Okay. So now we got 3, 6, and 9. We're going to see which one's going to be the closest in a bit. Okay? And then C, estimate at what time, or what times if you want to, you'll be at 20. So 20 meters would be about there, maybe. So we'd be there and there. What times do you think that could be? 19 seconds. And 6 seconds? Sure. Again, we're going to find out what these answers are in a bit. Now, to use our graphing calculator to actually help us solve this, we're going to need to come up with an equation. And we can choose sine or cos. Do we know what the center line is? It's 16. So our d value is going to be 16. Our amplitude is just our radius, so we know that that's 15. Our b value is related to the period. Your b value is 2 pi over the period. So in this case, our b value will be 2 pi over 20, since our period is 20. And then our c value is going to change depending on which function we choose. So we could choose a sine, cosine, negative sine, or negative cosine. You choose sine? Oh, I don't like choosing sine. You could choose sine. I mean, it's always a little bit harder to see the middle. The max and the min are the easiest to see. I would probably, if I would pick a favorite one here, not that any of them are that bad, I would probably pick negative cos. Because can you see if I choose negative cos, my starting point is here? And if my starting point is there, I have no horizontal shift whatsoever. So it'll make my equation a little bit simpler because I won't have to show any horizontal shift. But if you wanted to use a sine graph, then it's just a shift of 5 to the right. So here we go. Here's our equation. Our a value, our amplitude is 15, and since it's a negative cos graph, we'd have negative cos 2 pi over 20. Again, you could simplify that if you want, but you wouldn't need to. X, and then finally plus 16. So I don't have to deal with the c value. And then we go to our calculator and type this in. Negative 15 cos 2 pi over 20 plus 16. And then I'm going to go to my window and have it set up the same. And go in the negatives. Since we know that it goes up to 31, I'm just going to go a little past that, go up to 35. Maybe I'll make my, oh, that's my x scale, sorry. My x scale one period was 20, so maybe I'll go up to 25. Make it go every 5. We know that our maximum or y value went up to 31, so maybe I'll go up to 35. And then take a look at that graph. You probably aren't in radians. It's probably still in degrees. Did you remember the x in your equation? So go back to y equals. Sometimes if you forget the x, it'll come up as a straight line. Yeah, that's it. Okay. So here's our graph. If we want to find 22 seconds, our calculator, again, under the calculate menu, you can calculate any value you want. So we can put in 22 and 3.86. So our first guess of 3 was the closest. Once you type in one value, now if you wanted to find other values, like if you wanted to find out what 19 was like, there it would go. If you wanted to figure out what 14 was like. So again, you go to second, calculate. Second, calculate value on the first one, and then you can type in any number you wanted. And we wanted to estimate at 22 seconds, right above the trace. So you go second, and then hit the trace button, which gets to the calculate menu. And then 22 to find it. anytime you know a y value, and we saw this yesterday, anytime you know a y value, you can type that into y2. So we wanted to figure out when it was, how high? 20? At what times you were 20 above the ground? So if we hit the graph here, there's our 20. We can go second, calculate the intersection, 5, enter, enter, enter. One time is 14 seconds. I think we had said 19 seconds. We want to find another one again. Second, calculate. Number 5 for intersect. I'll move my cursor closer to the other one. Enter, enter, enter. 5.85. So if we look back at our guesses here, this one was quite a bit off. It should have been more like 14 seconds. And this one was pretty close. I think we just counted our ticky marks off a little bit here. 19 would be down here. So you guessed 6 and 14? That's not bad. So there's our first one, and how to use your calculator to solve for it.